Section 11.5, there are only 3 problems, and each problem has 2 parts. Find the derivative and evaluate the derivative. So we're using the implicit differentiation to find the derivative. We start here with the 2x cubed. The derivative of 2x cubed would be 6x squared by the power rule. Then the derivative of the y cubed by the chain rule would be 3y squared times the derivative of y. And the derivative of 3 is 0. The derivative of 0, likewise, is 0. So after this, we need to solve the equation for the y prime. So we will move the 6x squared to the other side. And divide both sides by negative 3y squared. 2 negatives will make a positive. 6 divided by 3 is 2. And we cannot combine x squareds and y squareds. So there is y prime. And that's what we will type in the first answer box. Now we want to substitute into that the values given up above. We'll be using a 4 in place of x and a 5 in place of y. So this would be a 2 times 4 squared over 5 squared. Now you can do that on your calculator. Now in fraction form, that comes out to be a 32 over 25. In decimal form, that comes out to be 1.28. Their blue writing seems to imply that they want it in fraction form. However, we're going to enter the decimal value. Since the technique is the same as the first one, we'll go through this a little quicker. The derivative of 4e to the y by the chain rule would be 4e to the y times y prime. The derivative of x squared by the power rule would be 2x. The derivative of y cubed, again by the chain rule, would be 3y squared times y prime. We need to solve for y prime, but it's in 2 places. So we need those together on the same side. So we'll move this term to the other side. That would give us a 4e to the y times y prime minus a 3y squared times y prime. We'll factor out the y primes. And divide both sides by the stuff next to the y prime. There's what we will be typing in our answer box. On the last problem, we need to begin with the derivative. The derivative by the power rule of x cubed would be 3x squared. The derivative by the chain rule on 8y to the 5th would be a 40y to the 4th times y prime. The derivative of ln of y by the chain rule would be 1 over y times y prime. As with the previous problem, we need all the y primes together on one side. We'll factor the y prime and divide both sides by the stuff next to the y prime. Now, I'm not exactly sure if it's going to allow us to type this as is, but we can give it a try. However, I want to show you how to simplify this expression. Normally, we don't allow fractions inside of fractions. So here we have this fraction and we have this fraction underneath the numerator. So to change that, we'll multiply top and bottom by the y. So the top then, when we multiply top and bottom by y, that would come out to be 3x squared y, and the y times 1 over y would give a 1, and y times 40y to the 4th would be 40y to the 5th. So that also will require less hassle on the typing. And substituting the 2 for x and the 1 for y would give a 3 times 2 squared times 1 on top, 1 plus 40 times 1 to the 5th on bottom. And again, if you need your calculator, then type it on your calculator. 2 squared is 4. 4 times 3 is 12, times 1 is 12. 40 times 1 to the 5. 1 to the 5 is a 1. 40 times 1 is 40. 1 plus 40 would be 41. Now, if you need to, you could type that into your TI graphing calculator and see does it simplify.